Hi, and welcome to Chat About Math Chat. We're talking about strategies for academic discourse in the secondary mathematics classroom today. My name is Ashley Roberts, and I am the secondary math coach. So, welcome. Thank you so much for being here today. If you would please have a paper and a pen ready to use nearby you, we are going to be using that today. So if you need to stop the video or pause the video real quick and go grab something to write with, go ahead and do that now, and then we'll get started. All right, let's do a little preview of our learning today using a strategy called pile of words. So you should see a pile of words here in the yellow box, and I just want you to think about these words for a second. So in just a second, I'll ask you to pause the video. I want you to read the words and think about which ones do you know, which words maybe do you need to define using some online resources, and then go ahead and capture your definitions and your thoughts in your notes. Pause the video now just to think about this pile of words. All right, let's continue previewing our learning for today. The next thing I want you to do is to group these words into categories. So think about which words share some common characteristics, and then think about how you would label that category of words to reflect their commonality. So go ahead and pause the video and group the words into shared characteristics by categories and then label them. All right, last step. Finally, make a prediction. Review your words, categories, and labels, and make a prediction about what you expect to learn today in this workshop based on your pile of words. What big ideas are you going to expect to explore today? I hope this gave you a little preview of our learning, tapped into your background knowledge, and you enjoyed looking at this little preview. Pause the video to make your prediction now, and we will come back and revisit this prediction at the end of the session. All right, let's go ahead and get started on mathematical discourse. The three things we'll be talking about today is what is it? What's mathematical discourse? Why is it important? And then give you some strategies to get started using mathematical discourse with your students in your class this fall. All right, mathematical discourse. We're going to do a journal jot to stimulate your thinking today. In just a second, I'm going to ask that you pause the video and that you take a second to read what's inside the blue box. This is the NCTM, the National Council for Teachers of Mathematics. This is their definition of what discourse in the mathematical classroom looks like. So take a second to read their definition, and then I would like for you to choose two of the questions in the thought bubbles on the right-hand side to journal jot your answers to. So take a second, pause the video, read about discourse, and answer two of the thought questions on the right. I will see you back in the presentation in a few minutes. All right. I hope you enjoyed reading that definition of what discourse is and thinking about what happens in your classroom. Let's take a quick poll. Which of the following are examples of mathematical discourse? Let's see what you think. A student asks whether she should show her work. B, a student writes to explain his mathematical thinking. C, a student says, I noticed a pattern that will always work. D, the teacher provides a counterexample to a student's method. Or E, students discuss the conditions in which an idea won't work. So take a second and think about it. What do you think? Which of the following are examples? There can be more than one answer. All right, let's talk about which ones are examples. More specifically, which ones are not. Answer choice A is not an example of discourse in the mathematical classroom. Here, a student is asking whether or not she should show her work. This question is more about procedure and direction and directions. It's not directly related to the mathematical content or her thinking about mathematics. So just a student asking a question like this is not mathematical discourse. The other one that is not considered discourse is D, when the teacher provides a counterexample to a student's method. Really, as you read in the definition, we're trying to get discourse between students. We're trying to have a student-to-student discussion, not a teacher-to-student discussion. So we're trying to position the students as the facilitators of learning and not necessarily the teacher providing all of the counterexamples. Something that might have shocked you is that B is an example of mathematical discourse. So students writing to explain their thinking is considered communication and discourse in math. A student noticing a pattern, of course, is discourse, and students discussing the conditions in which an idea won't work, maybe some error analysis, that is considered discourse. All right, on this screen, you'll see some different types of mathematical discourse that can happen in your classroom. On the left-hand side are the different types, and on the right-hand side, these are the descriptions of those types. These types of discourse start at the top, at the most basic level of discourse and communication, and they progress in a continuum down to the bottom. And the bottom is the most rigorous or most complex types of discourse that could happen in a classroom. Take a second to pause the video and try to match the type of discourse on the left with its correct definition on the right. I'll give you a second to pause the video now. All right, how did you do? Here are the different types of mathematical discourse that could happen in our classroom over the course of the day. At the top, you'll see the most basic form of discourse is answering questions. So basically, this is where students give a short answer to a direct question. Usually, just answering has a right or wrong answer, or it's a simple yes or no, or what is the solution. As we progress down the list, we move on to sharing and explaining. These are more simple statements where students are not necessarily asked to explain the how or the why or even give any sort of justification for their thinking, but it is a little bit more rigorous than just answering. As we move down, this is where we want to get our kids to. We want to get them into questioning each other and even challenging each other. We want them to clarify their understanding and push others and to reevaluate their thinking. Even most rigorous and most successful types of discourse are when we can get students relating and making predictions. Having them make connections to prior knowledge or experience is huge. We want them to do that for themselves. And then we want them to make conjectures based on their understanding. We want them to provide justification and explain their thinking. And then most complex is generalizing. We want them to shift from specific examples to more general cases on their own. Take a second and think about what type of discourse happens most often in your classroom and how this fall you can maybe try to start nudging your students down this list into a little bit more complex and more effective discourse. All right, grab your pen and paper again and create a T-chart that looks like this. You'll have two columns. Title the left-hand column, "What are teachers doing?" and title the right-hand column, "What are students doing?" We're going to think about what mathematical discourse in a classroom looks like. So if you walked into a classroom where really amazing mathematical discourse was happening between students, what would you see the teacher doing and what would you see or hear the students doing? Try to sort the actions on the colorful little cards on the right into two categories: teachers doing and students doing. Pause the video to sort each of those statements now. All right, how did you do? Here's what you could expect to see teachers doing in a really rich classroom full of good communication. Teachers should be engaging students in the purposeful sharing of their ideas. We should be ensuring progress towards mathematical goals by making explicit connections to approaches and reasoning. We should also be facilitators of discourse among students themselves by positioning them as authors of their own ideas. So no longer is the teacher seen as the sole expert and the sole communicator of knowledge in the room. We want the kids to learn and grow from each other. And finally, and probably most importantly, the teacher is the one selecting and then ordering different student approaches and considering which ones to use for whole class discussion. Now, what would you see the students doing or maybe hear them doing? You would hear them presenting and explaining their ideas. This could happen in pairs or with shoulder partners, even a small group for table talk, or as whole class. You would see them identifying how different approaches to solving are the same or how they're different. Maybe some comparing and contrast on how different strategies work. You would see students seeking to understand the approaches used by their peers and even asking clarifying questions just to make sure they've got it. And finally, you would see students listening carefully and critiquing the reasoning of other peers. All right, here is a sample script, a classroom example of what mathematical discourse could look like. Take a second and read through this script of what happened in a real teacher's classroom. After you've read the script, take some time to consider the questions in the thought bubbles around the script. Maybe even jot some of your ideas in your notes. Really try to pay attention about why the teacher asked certain questions, or think about how the students benefited from this conversation. Pause the video now to read and reflect. All right, why is mathematical discourse important? So what, Ashley? Okay, I know what it is and what it looks like, but why do I need to have my kids do this? Here's 5 main reasons. Number 1, it builds your students' mathematical fluency. Don't we want them to be fluent experts in making mathematical connections on their own without relying on us, the teacher, to do it for them? They have to start learning and listening from each other like real mathematicians. Second of all, it establishes the student as the expert in the room, which really builds their confidence. So no longer are they walking into a mathematical classroom thinking the teacher is the expert, she knows everything, and I know nothing, and I can't get it. It really establishes the kid as, no, you have good thoughts and ideas and approaches to solving. It'll be amazing how you see their confidence grow. Thirdly, it enables students to demonstrate mastery of concepts. So no longer are we solely relying on a paper, pen, multiple choice, summative assessment. We can gather some informal data that let students show us they're mastering concepts in a new way. Thirdly, why is this important in our class? Well, it allows students to share their ideas, which increases their interest in math and their participation in math. So no longer do we have a room full of passive engagement or passive listeners that are just taking in information. We're drawing our students in to actually collaborate and be a part of the mathematical culture in our room. And finally, listening to that mathematical discourse provides us as teachers the opportunity to push the thinking of students that maybe always get the right answers. Now we have a way to challenge them and to push them further. But it also allows us to address gaps and misconceptions as they arise. And as we hear what students are thinking, we can address them on the spot. All right, now that we know what discourse is and why it's important to have it in our classroom, let's think about some strategies we can use to get started in our classroom. The first thing you'll have to do as a teacher, and I think this is the most important thing, is intentionally choosing a task that allows for multiple pathways or multiple entry points, and maybe even multiple answers. So we're moving away from a question that has one right or wrong answer and has multiple ways of solving. And these engage and challenge all of your students' thinking in your classroom. So for example, let's look at an example of a traditional task and maybe a more intentional task. All right, here's the first example. Think about this classroom task. I'm going to ask my students to find the mean, the median, and the mode of this following set of numbers. Take a second to pause the video and go ahead and calculate the mean, median, and mode of these set of numbers if you'd like to participate along with us quickly. But take a step back and think about if this was your classroom and you had given this assignment or this task to partners or small groups around the room. Think about what sort of discourse you would hear. As you walked around the room, what would the students be saying to each other or talking about? If it was in my classroom, they may be saying things like, okay, you find the mean and I'll find the median. Or, hey, what did you get for the mode again? Take a second and actually solve this and think about what sort of conversations you would hear. All right, now consider task 2. Take a look at this. Now in partners or in small groups, I want my students to create a data set with at least 7 values so that the mean is 20, the median is 12, and the mode is 23. Take a second to pause the video and challenge yourself to do that. But then also take a step back and think about, as a teacher, as you're walking around the room, listening to conversations, what would discourse be like for this task? What would you hear students saying and talking about? How would the classroom look and feel differently? Pause the video if you want to try the challenge yourself. And also think about the difference in the types of discourse supported by each of these tasks. All right, so not only is it very important to choose those multiple entry type tasks to create that rich discussion, you also want to encourage your students to listen carefully to one another's ideas. You want them to disagree or agree, to question and to clarify each other. Remember, our goal here is to shift from that teacher to student ping-ponging conversation where I'm asking the questions and the students are just simply answering. And we're making this shift into real student-to-student conversations where they're really listening to and clarifying each other. Here's an idea on how I've seen some teachers do this. They call this table talk, and I've seen them even print out and tape these sentence starters or these sentence stems to each desk in their classroom. So these sentence starters give you ways to add on. You would like to agree or disagree with each other. And it gives them a cue for how to revoice or clarify. I want my students to say, I heard you say something about blank. Could you repeat that? Or wait a minute, could you talk more about this part? By providing these cues, you make a pathway for every student in your classroom to be an active participant in the classroom discussion and the classroom culture. Providing sentence stems are also huge for our ELL learners. It gives them a place and a voice to start their question. So, like I said, I've seen some teachers print these stems off and tape them to their desk so that the expectation is that during table talk time, we're using these sentence starters to add on, to revoice, and to clarify in small groups. All right, here are some other mathematical sentence starters. And I have even seen teachers print these off in poster size and have them posted around the room. You just have to constantly refer your students to take a look at these posters as you're facilitating these small group or whole group discussions. When you want your students to report a solution, we're not just giving an answer, we're having them say things like, I believe this is the correct answer because, or I can verify my answers by. Do you see the difference there in just reporting an answer versus reporting a solution? There are some sentence stems to get students to report a partner solution. So maybe after you've done a think, pair, share, and now we're sharing out whole group, here's some ways where you can report a partner solution or even reporting a group solution. And finally, some other sentence starters to affirm or disagree. So we have to teach our students how to disagree respectfully, like real mathematicians do. I don't agree with you because, or I got a different answer than you, or I see it another way. So really just creating that safe space where they're willing to take those risks and agree or disagree with others. All right. So in addition to creating those open-ended tasks and then getting students to talk and question each other, it's also important that we as teachers ask really intentional questions that extend our students' thinking and get them to clarify and justify their ideas. Here are some example questions. I will just point out a few of my favorites, but you may want to pause the video and really dive deeper into some of these teacher questions that you may want to ask your kids. For example, one of my favorite questions is question number 34. When I want my students to reason mathematically, I like asking, how did you organize your information or how did you organize your thinking? We've all had those students that struggle with showing their work and getting students to discuss their work with each other. It's really important that they organize their information so that other students can learn from that. When I have students that are having trouble with just problem comprehension and they're saying, I don't know, I don't get it, here are some questions I can ask back to them. So I really like question, let's see, 46. What do you know about this specific part? Or question 47. Which words are most important in here? And why did you pick those as the most important words? These are just great teacher questions that you can ask students to get them thinking and clarifying. Here are some more questions that you as the teacher can ask your students to help them invent and solve problems. So instead of just asking what is the answer, we could ask questions like number 66. What is your estimate or what is your prediction? Or maybe question 67. I love this one. Don't tell me your answer. Tell me how confident you are in your answer. I also like, how could you check your steps to make sure this is the correct answer? Or what are some other possibilities here? We don't just have to ask for solutions, we can really get kids to invent and really think about their problems. If you liked these sample questions, we actually have a free poster download for you by Curriculum Associates. So if you want to grab your phone or another smart device and scan this QR code now, it will take you straight to those questions we were just looking at, but in a really pretty PDF poster format. There are 100 questions to promote mathematical discourse on there. If you are interested in having those printed in color or maybe even poster size and laminated, don't hesitate to reach out to me, ashley.roberts@kellerisd.net, and I can help you with that. I would use this poster in my classroom by posting it maybe on the back wall, so the opposite of where I'm typically teaching from, just so I as the teacher could look up and refer to it in the moment as I'm teaching. I may even print them off and have them at my desk or at my small group table so I can ask these questions during small group time or when I'm working with individual students. It would also be helpful to have these 100 questions as I'm planning lessons so that I can intentionally and purposefully put in some of these questions into my lesson plan ahead of time. If you're anything like me, I do not easily think of these questions on the spot in the moment, so it is helpful to think of them ahead of time and have them posted around my room for me to refer to. So I'll give you a second to pause the video and scan to access those 100 teacher questions. All right, in summary for today, we are going to complete a strategy called the 3 W's, or the 3 whats. So in just a minute, I'll have you pause the video, grab your paper and pen, and answer these 3 what questions. What did you learn today? So what? What's the importance or the relevance? Why does learning about mathematical discourse matter to you? And now what? So, what are you going to do now? How does this affect your thinking? Maybe you used to think something and now you've changed your thinking. How will you plan for student discourse in the future? What is student talk going to look like in your classroom this fall? Maybe it's going to be different. And finally, don't forget to revisit your prediction we made at the beginning of this training when we did pile of words. Was your prediction accurate? Did you learn what you thought you were going to learn? And are there any additional words or terms that you want to add to your pile of words from the beginning? Take a minute, pause the video, answer your 3 what questions, and revisit your prediction. All right. I hope today's training was super impactful and super helpful to you. I know that when I see students in the classroom talking to each other, it is so much more impactful and they are so much more engaged and motivated and then really making those mathematical connections. So I hope you enjoyed the training today. If you have any questions, if you want to brainstorm mathematical discourse further, I would love to be a thinking partner with you on this. Please reach out to me. Again, my name is Ashley Roberts. I'm the secondary math coach. The secondary math coordinator is Reese Brooks, and she would love to partner with you as well. And she did help with today's presentation. So thank you again so much for your time. I hope you have a great day.